Hello and welcome to day 3 of solving systems of equations. Today we're going to look at the elimination method. It's also called the linear combination method. We've talked about graphing, we've talked about substitution, and today we're going to do this third method. And it's usually the method that students like the most. So let's go ahead and get started. So linear combination elimination, what does that mean? Well, let's take a look at both or all three of these words and see what we come up with. So what does linear mean? Linear means we're talking about lines. Combination means we're adding or putting things together. Elimination means we're getting rid of. Okay, so we are using linear combination slash elimination to add up the equations, these linear equations, and we are going to eliminate one of the variables. And when we eliminate one of the variables, it's kind of nice. We already get a variable, and then we can plug that variable back in and find your x and y, your intersection, or your solution for these systems of equations. So instead of being the terminator, I am the eliminator. So today we are eliminating. Just something a little fun, sorry. Okay, so example number 1. The first thing we want to do is we want to have a system. A system is 2 equations. And we're going to line them up so the x's are lined up, the y's are lined up, the equal signs are lined up, and the constants are lined up. So this is all nice and lined up for you. And so what we want to do is we want to add the equations together so we get rid of a variable. So my question to you is, if we were to add these 2 equations together, would we eliminate a variable? And the answer to that is yes. 5x and negative 5x would eliminate or cancel out, and I would be left with 4y equals negative 16. Now I divide both sides by 4, and I get y equals negative 4. So my solution is the y part is negative 4, and now I need to find the x part. So I'm going to plug negative 4 back into the top equation, and I'm going to go ahead and see if I can find out what that solution is. So 5x minus 4 equals 6, 5x equals 10, x equals 2. So we're going to see if that really works, because 2 works for the top one. Let's make sure 2 negative 4 works for the bottom equation. So I need to check it in the bottom equation. So negative 5 times 2 plus 3 times negative 4, does that equal negative 22? So negative 10 plus negative 12, does that equal negative 22? And I would say yes, negative 22 equals negative 22, so that does check. All right, let's do another one. Solve the system by elimination. If we added these 2 equations together, would a variable eliminate? I'm not seeing that a variable would eliminate. We would get 2x and a negative y. That doesn't help us. If we do that, 2x minus 1y equals negative 10, nothing has happened here. We still have x's and y's. So if that's the case, what we need to do is we need to change one of those lines so that we can get them to eliminate. So what we're going to do is I'm going to take and multiply the whole bottom equation by 3. And if I do that, then what happens is, okay, let's take the top equation and rewrite it. The bottom equation now becomes negative 3x plus 9y equals negative 15. So now when I add these 2 together, don't forget to multiply everything on both sides by that 3. A lot of times this constant is missed. All right, so when I do that now, I can see that these x's are going to cancel out. We've eliminated them. And so now we can add up the 9y and the negative 4y and get 5y equals negative 20, y equals negative 4. And so now that I have a y, I can find my x value by plugging that y back into the top equation. And negative 4 times negative 4 is 16. And I subtract 16 on both sides, and I get 3x equals negative 21. And so x equals negative 7. So hopefully if this works, it should work in the other equation. So I'm going to plug it into the other equation. I'm going to have a negative 7 plus 3 times negative 4. Does that equal negative 5? So 7 minus 12, does that equal negative 5? Yep, negative 5 equals negative 5. So that is the solution to this systems of equations. All right, let's do one more example. One more example, here we go. As you notice, these x's are not going to eliminate, the y's are not going to eliminate. And so sometimes, like in the last example, I had to multiply one equation by a number. I might have to do both equations by a number. So this time I'm going to get rid of my y's. I like that I'm going to get rid of my y's because they're already opposite in sign, and I like that because if they are opposite in sign and the same number, they cancel each other out. So what times 7 and 2 multiplied together would make 14. So I'm going to try to make my y's 14. So I'd have to multiply the top equation by 2, and I'd have to multiply the bottom equation by 7. And so when I do that, I get 4x minus 14y equals negative 20. Remember, don't forget to multiply that last constant by the 2. And then I get on the bottom equation, I get 21x plus 14y equals 70. And I just like how that 14 and negative 14 eliminate each other. And when that happens, then I get 21. 21 plus 4 is 25x equals 50. X equals 2. So then I'm going to see what I can get for my y. I'm going to plug that 2 back up into the original. And I'm going to use the original equation. Remember, when we're doing this, we always go back to our originals. 2 times 2 minus 7y equals negative 10. 4 minus 7y equals negative 10. Subtract 4. I get negative 7y equals negative 14. Divide by negative 7, and I get y equals 2. So hopefully 2 is the answer. So I'm going to go back to the top, or excuse me, I'm going to go back to the bottom equation, and I'm going to plug 2 in. I already know it works in the top equation because this was the top equation. Okay, now we're going to go to the bottom equation. And 3 times 2 plus 2 times 2, does that equal 10? That's my question. So does 6 plus 4 equal 10? Does 10 equal 10? Yes, it does. So 2 is the answer to this problem. So sometimes we have to multiply one equation by a number, and sometimes we have to multiply both equations by two different numbers. And so that is the end. And hopefully this helps you for tomorrow. And we'll see you tomorrow.